Turning the audio up to 11 to get started. Turning the audio up to 11 to get started. And just like that, we're live. So this is going to be a little bit different. There's a whole bunch of topics that I want to cover, and I just can't get to them all. And so I thought about how could I cover things like a review of the PicoScope without having to go make a full video, and I thought, why don't we try doing it live? So this is the first time I'm doing a live stream, so I'm only going to cover a couple of things because I want to test some things out, see how some things work, so please give me some feedback. All right, so the first thing I want to double check is that the audio is, well, autoing. Not really sure what the right phrase is. Okay, so this, oh wait, you can't see that yet. This is the PicoScope. Or at least this is the software interface to the PicoScope. And so what this is it's a USB-based oscilloscope. And so one of the cool things about it is it has a built-in AWG, or arbitrary waveform generator. And so we're going to take a look at that, and I want to show you something that I found earlier. So the first thing I'm going to do is go and turn on a signal. And it's going to be a sine wave of 100 kilohertz. And so we see our sine wave now. And if I wanted to go and measure that, we can just go up to the measurements and turn that on. And we can see that we're measuring 100 kilohertz, which isn't a big surprise because it's, well, looping around itself. But the more interesting thing is to go look at an FFT. But before we do that, I want to expand this waveform and show you something that I thought was somewhat interesting. It's the wrong control. So notice on this waveform how it's not a nice clean signal, and that's because this is an arbitrary waveform generator, which means it's actually a digital to analog converter generating the waveform that we see. And so unlike a traditional signal generator, which would actually use like some kind of oscillator to make a sine wave, this is doing it digitally. And so we're actually seeing a little bit of that in the waveform that we're looking at. And so what this means is if we go look at the FFT, we'll see something interesting. So scrunch it back up. And now I'm going to go and turn on the FFT, which on the PicoScope is the spectrum view. Okay, so the top screen is what you would call a time domain because we're looking at it in time. And then the bottom screen is the frequency domain because we're looking at it, well, across frequency. So if I go and look at this big spike, this is where most of the signal's energy is. I can click on it and see it's right about 0.099 megahertz, which is right about 100 kilohertz. But notice something, there's a spike here, here, and here. And if I go look at those, it's going to be around 200 kilohertz. And you can probably guess that this one is around 300. So what's going on here? Well, again, this isn't a real sine wave. If this was a real sine wave, then there would only be one spike because there'd only be one fundamental frequency. But because you can think of this as a whole bunch of square waves that are creating the sine wave, we start to see harmonics just like we looked at a square wave. The really interesting thing is over here where we see a spike around 1.4, or if I round up, 1.5 megahertz. And so if you do some math, you might say, well, that doesn't really add up, or you can't really evenly divide into that. So watch what happens when we change the arb to go to something nearly random like 34 kilohertz. All right, so I change it on the signal generator. I stop the scope, so I got to run it again. let it build up its buffer, and you should already notice a couple of things. So first, we now have a spike down here, and it's at 30, this is showing 36 megahertz, probably just a resolution thing. But if you notice, back out here, we still have a spike around 1.5 megahertz. So my guess is on this unit, in its arbitrary waveform generation circuit, my guess is that the ARB, or the AWG, is designed or has a 1.5 megahertz clock driving its digital analog converter, and that's why we could see that spike. All right, I wanted to show that real quick. Let me go see if you guys have any questions in the chat. All right. Okay, we're not getting into lyrics, thanks. But yeah, it is pretty spiky. All right. Wow, this is like really, really delayed. Voltage dividing base, calculation, 12-volt charger, and relay. Saeed, I'm sorry, but I don't understand how to answer your question. Sapper John, you could actually use this in an automotive application. One of the interesting things is that because it's USB powered, is that it can be powered directly from a laptop. In fact, that's what I'm doing in the setup right now. And so you can easily take this out to a car, hook it up, and take a look at, like, I don't know. I was going to say the CAN bus. Let me check something. Got to turn on 2 channels real quick. Yeah, so let me show you something really quick. So one thing I'm not going to cover in this tutorial, but if you go check out the blog post I linked to in the description, I did a I2C decode example where I was looking at the I2C bus between an Arduino and an LCD. And so one of the things that the PicoScope software does is it can do serial decode. And so here's a list of all of the different standards that it can decode. And so, for example, if you want to do something in the car and decode traffic on the CAN bus, you could use this to take a look at that. Of course, you could use it for power circuits and other things as well. But yeah, you know, it's, like I said earlier, it's ideal for a car situation because it's actually, it can be entirely battery powered. All right. Oh, actually, and I don't remember if it still exists, but a long time ago there was the MOST network, M-O-S-T, and I don't even remember what it stands for anymore. But it was a fiber optic network that was meant to replace the copper-based or wire-based CAN network. I know for a while high-end German cars had it. I don't know if other manufacturers or if it's still around, but in that case you would need like what would be called a probe, which is really just a fiber to electrical converter. Plug the fiber into that, and then it splits it, retransmits it, and then you can decode. But for the electrical CAN bus, it's no big deal. All right, yeah, on the microphone, it's actually, I'm not using the microphone I like to use. It's this really cheap lavalier that I have. I have a much nicer one, but it's not wireless, and I didn't want to be tied to a wire for this one. So I will be looking at better microphones. It's just the only one I had to use up tonight. Stefan, I don't understand what you mean by the 250 kilohertz thing. Funny thing about the audio, I had my headphones on earlier while testing another stream, and I could hear my neighbor doing their laundry. I can't hear it when I can't hear it myself, but the microphone was able to pick it up, and so that was kind of crazy. All right. Yeah, it can't be the laptop microphone because it's disabled. So yeah. Also, when I do tap it, which I did earlier, I can hear it from the monitor on the other side of the room. It's a very omnidirectional mic. In fact, the only other time I've ever used this microphone was in episode 11, the MOSFET episode. Yeah, okay. I get that you think it's not this microphone, but I can hear it myself when I tap it. So I know it's transmitting through. And if I go and look at my laptop microphone, well, all right, I'm going to try that and see what happens. Let me know if this changes. I don't know what a COMSOL multiphysics is. Yeah, okay. Yeah, I guess me sitting and staring at the screen is not all that interesting. But I do want to see if I can figure out what the audio is going on. I mean, the other thing I can do, I can turn this up, but the problem is it's picking up so much room noise and static just from the microphone. So, yeah, Ray, actually on the communications protocol thing, that's actually something that I want to cover is, and what I haven't decided is if I want to try to do all of them in one video or do individual videos. One of the things that, okay, fine, Liberty, I know you're trying to be helpful, but seriously, I'm looking at my settings and there is only one microphone available. So I don't know what else I can change. So in terms of the communications protocols, I do think I want to do something that that compares what each of them are and sort of where they get used. One of the things I'm going to try to start doing with videos is instead of just doing a pure tutorial, is do a project along with the tutorial. So for example, if I'm going to do an I squared C tutorial, I want to do a project where I'm actually using I squared C. So maybe it'll be something that, maybe it's like a password lock or something where we're storing stuff in EEPROM. And so I think if I do it that way, I won't do all of the protocols at once, but we can look at what a couple different ones are. All right, Sever John, do you have any experience with Arduino? Yeah. Measuring blow-by on an engine. I want to test pressure across a known orifice to calculate flow. Well, I don't know what you mean by Arduino math. I mean, The Arduino is just C++, so if you know what the math that you have to do is, then just do that math. So I think, the reality is what you're probably asking is how do you get the actual information from the sensor, and I don't know engines well enough to tell you how to do that. But if you can find the right source of information to tap, then it's going to be pretty easy to do the math. So since you did ask about Arduino, I will mention that my plan is to expand, or is to do some Arduino tutorials live, because if you go look at baldengineer.com, I've got tons of tutorials there, and a few of the topics I think would work better in video, and so I think it would be kind of cool to do like explain how millis works, or how to use millis correctly through video. So we'll look at trying to do that. All right, so if you're just joining, I just wanted to repeat something I said earlier. So this is the first time I'm trying to do a live stream. One of the reasons I'm doing this is because I have a lot of videos I want to do, but if you notice when I make my videos, I put a lot of work into them, and so I wanted to differentiate. And so, for example, in this video, I want to talk about the PicoScope. It's a USB-based scope. I'm going to show something else on that in just a minute. And so I want to do sort of videos like this live. And then it gives you a chance to ask questions as well. I still keep doing tutorials, and then I'm also looking at some project videos that will be coming up pretty soon. Okay, so what was I just thinking of? So I'm just going to switch back to the PicoScope real quick. Send stuff in the chat. I'll get to it in just a minute. All right. So we were just looking at the serial decode. Something I wanted to try out, and I haven't even looked at this myself yet, so I don't know what's going to happen when I try this. I want to turn the spectrum off. Close that one. I wanted to try out math, and I don't know I don't know where it's at. Math channels. All right, so I'm going to do A. I want to invert A, and if I click OK, do we see that? Yep, we do. So if I expand this out, so it looks like wow. The time-based controls don't work the way I expect them to. I have to recapture? Yeah, that's what I did wrong. All right. So we should be inverting. I wonder why it's not inverting. Oh, because I turned channel B back on. Let me turn that off. All right. So here we're looking at this inverted waveform. That's kind of cool, actually. Now I bet it will let us subtract those two. And if we subtract those two, it should be a straight line. Oh, or can I only do one math function at a time? Oh, bummer. Ah. All right. Well, I've done this on other scopes where you wonder. Oh. No, it's not. That's B as in the channel. Okay. So, all right. Well, I'll tell you what. If anyone knows how to do the waveform math, let me know. I'm gonna try something real quick. I'm going to do this, and I'm going to say I want to add the screen capture, and All right, not working out. Okay. Okay, guys. Again, this was the first one. I just wanted to give this a shot, see how it works. I appreciate everybody coming in and chatting, especially the ones that didn't complain about the microphone. If you got ideas for videos, leave them with, leave a comment, send a chat, send an email, find me on social media. And my favorite catchphrase, if your circuit's not working, remember, just add ohms.